But before we solve for length is equal to 4, which is our final solution, let's try to see that whether we can derive any algorithm so far. And we are successful in reusing the solutions from the previous sub-problems, like for 24, 6, and all. But are we coming up with any algorithm? So let's see. Let's try with 0, 1, and 2, right? And let me maintain like 3 variables, I, j, and k. So by I, j, and k, I mean that, for example, for 0, 1, and 2, right? So I would be, I will start with I, is here, 0. K would be starting from k, and then we'll expand to move to j. So in other words, we'll start from k, and then from, as we have done here, right? So k here in this scenario, starting from this k, we multiply until j, and similarly, k will move from this position to this position, and then we multiply for I and k, and then use that formula until we reach j. So let me write it down first. It will be easier to understand. So taking this example for 0, 1, and 2, we have seen that if I take I is equal to 0, this one, and k is equal to 1, and then j is equal to 2, and then we keep on moving through it. So this formula, right, 24 plus 1 into 4, for this part, only 1 multiplied by 2 multiplied by 4, it can be written as same as this formula here, which is, it should be row of I, because row of I is 1, that is I here is 0, and the 0th index, the row of I is 1, right? Multiplied by 2. 2 is the column of k. And here, we are actually using the multiplication form here, right? So the column of k, that is, then, or we can also use the column of I here, because we are starting with k is I is equal to 0. Sorry, we have to start with I is less than or equal to k. So we have to start with 0 condition. And then we have to use this loop. So we start with I is equal to 0, k is same as 0, and then we move to until we reach to the j of 2. So here again, this formula for 0, 1, and 2. So we already got the answer for 1 and 2 in our previous problem, which is 24. And for this pattern, right, 1 multiplied by 2 multiplied by 4, we can write this using our like in the base of I and k and j. So it would be rows of I multiplied by columns of k multiplied by column of j. If we take this, it's same as 1 multiplied by 2 multiplied by 4. Okay, so this covers for 0, 1, and 2. Now, the condition says that we have to move through k until we reach till j, right? So this is where it comes for the second option here for length of 3. So let's see it again here if this formula is correct. Similarly, because we have to move from iterate k from 0 to 1 until it is less than 2, our j is 2. So we have the second condition here, which is corresponding to this one. So k has now moved from 0 to 1 now. That's why we are using this parenthesis between 0 and 1. So k is now 1 here. So again, for 0 and 1, we have already calculated 6. And now for this part, right, 1 multiplied by 3 multiplied by 4, it's the same formula as this one. So let's see. So row of I, that is row of 0, is 1, right? 1 multiplied by column of k, which is matrix 1, is 3, multiplied by columns of j, which is again 4. So this 1, 3, 4 is exactly same as this one. So right now we using this formula. This formula. It's not very straightforward to derive, but we have to look very closely by dividing it. When we break it down, we have to just maintain these 3 variables and see that whether we can derive this algorithm. And this is the algorithm that we came up. And we are also reusing the the sub problem answer that we have already calculated before. So this is what we have to come up with this algorithm by just looking carefully and seeing that whether we can use the previous sub problems, and is there any pattern being followed. Similarly, for this part, it would be same. Again, I mean, let's if we just break it down and you can do it on our own. Let's start with length equal to 4. But this is the formula. I mean, we just checked that how it is going to work. Similarly, for 1 and 2 to 3, we start with k is equal to 0 and k is equal to 1. And we will see that this part, 2 multiplied by 3 multiplied by 3, and similarly this in brackets. This would be exactly same formula as we have derived here using this iterative approach of I, k, and j. So now being said that, let's start with length equal to 4, where we will again use the same formula and see whether we can again derive the formula for the domain or the subdomain problems that we have already solved, whether we can formalize that as well.